Welcome to YQ Academy, SQL. Interview Questions and Answers. 1. What are cursors? Cursors in SQL Server are database objects that allow you to retrieve and manipulate data row by row. They provide a way to process data sequentially, enabling you to perform operations on individual rows or subsets of data within a result set. Cursors are typically used in scenarios where you need to perform complex row-based operations or procedural logic that cannot be easily achieved using set-based operations. 2. Explain different types of cursors. 1. Forward-only cursor. This type of cursor is the simplest and most efficient. It allows only forward scrolling through the result set, meaning you can only retrieve rows in the order they were fetched. Once a row is fetched, it cannot be revisited. This cursor type is read-only, and changes made to the underlying data by other transactions are not visible. 2. Static cursor. A static cursor creates a temporary copy of the result set in tempdb. Once the cursor is opened, it provides a fixed snapshot of the data. Modifications made to the underlying data by other transactions are not reflected in the result set. Static cursors support scrolling in both forward and backward directions, and the same row can be fetched multiple times. 3. Dynamic cursor. Dynamic cursors are more flexible compared to forward-only and static cursors. They reflect all changes made to the underlying data by other transactions as you scroll through the result set. Dynamic cursors support scrolling in both forward and backward directions and allow fetching rows multiple times. They can also be updated, and the changes made using the cursor are reflected in the database. 4. Keyset-driven cursor. Keyset-driven cursors are similar to dynamic cursors but provide better performance in certain scenarios. They store a unique identifier for each row in the result set, called a keyset, which is used to maintain the position within the result set. Keyset-driven cursors reflect all changes made to the underlying data, and they support scrolling in both forward and backward directions. However, they do not support fetching rows multiple times. 3. What are the disadvantages of cursors? 1. Performance impact. Cursors can have a significant performance impact, especially when dealing with large result sets. Cursors process data row by row, which can be slower compared to set-based operations that process data in bulk. Cursor operations involve additional network round trips, memory usage, and processing overhead, which can lead to decreased performance and increased resource consumption. 2. Increased locking and blocking. Cursors may hold locks on the underlying data while they are open, potentially causing blocking issues. If a cursor is not closed or deallocated properly, it can result in long-held locks and increased contention, negatively impacting concurrency and overall database performance. 3. Resource usage. Cursors consume additional server resources, including memory and temporary storage. Each open cursor requires memory to store the result set and other cursor-related data. If multiple cursors are used concurrently or if cursors are not properly closed or deallocated, it can lead to increased memory usage and potential resource contention. 4. Limited scalability. Cursors are typically processed row by row, which can be less scalable compared to set-based operations. As the result set grows, cursor operations may become slower and less efficient. In scenarios where performance and scalability are critical, it is generally better to use set-based operations instead of cursors. 5. Complexity and maintainability. Cursors introduce additional complexity to SQL code and can make it more difficult to understand, maintain, and debug. Code that uses cursors tends to be more procedural and less declarative, which can make it harder to optimize and troubleshoot. Cursors often require additional error handling and exception management, further adding to the complexity. 4. How can you avoid cursors? 1. Use set-based operations. SQL Server is designed to handle data in sets, so leveraging set-based operations is often more efficient than processing data row by row. Instead of using a cursor to iterate through each row, formulate a single SQL statement or a series of statements that operate on the entire data set at once. 2. Use joins. Utilize the power of SQL joins to combine data from multiple tables and perform operations on the combined result set. Joins allow you to retrieve data that meets specific criteria from multiple tables without the need for cursors. 3. Aggregate functions. Utilize aggregate functions such as sum, count, AVG, min, and max to perform calculations and summaries on groups of rows. Aggregate functions operate on sets of data, allowing you to derive meaningful results without the need for cursors. 4. Subqueries. Use subqueries to nest one SQL statement within another. Subqueries can be used to retrieve a subset of data based on specific conditions and then use that subset in subsequent operations, avoiding the need for cursor-based processing. 5. Temporary tables or table variables. Consider using temporary tables or table variables to store intermediate results during complex operations. By populating temporary tables or table variables with the required data, you can perform set-based operations on the temporary tables instead of using cursors. 6. Batch processing. If processing a large data set, consider breaking the operation into smaller batches. Process each batch using set-based operations, commit the changes, and then move on to the next batch. This approach can help reduce resource consumption and improve performance compared to cursor-based processing of the entire data set at once. 7. Optimize queries. Review and optimize your queries to make them more efficient. Ensure that you have appropriate indexes, use proper query hints, and leverage the query optimizer to generate optimal execution plans. Well-optimized queries can often provide significant performance improvements over cursor-based processing. 5. Write down the general syntax for a select statement covering all the options. Select specifies the columns or expressions to retrieve from the tables. Distinct. Optional keyword to remove duplicate rows from the result set. All. Optional keyword to include all rows, including duplicates default behavior. From. Specifies the table or tables from which to retrieve the data. Join. Optional clause to join multiple tables based on specified conditions. Various types of joins, e.g., inner join, left join, etc., can be used here. Where. Optional clause to filter the rows based on specified conditions. Group by. Optional clause to group the result set by one or more columns. This is typically used in conjunction with aggregate functions. Having. Optional clause to filter the groups created by the group by clause based on specified conditions. This is similar to the where clause but operates on the grouped data. Order by. Optional clause to sort the result set based on specified columns. ASC. Optional keyword to sort in ascending order default behavior. Desk. Optional keyword to sort in descending order. This is the end of our SQL interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.